Magnetic resonance imaging, or more commonly referred to as MRI, is a scanning technique used to create detailed images of the human body. The physics behind the MRI was discovered simultaneously by Felix Bloch and Edward Purcell in the 1950s. Years later, the first clinical image using an MRI machine was obtained by Dr. Raymond Damadian. During an MRI, a person lays on a movable table that is then slid into a donut-shaped opening of the machine. The machine then scans specific portions of their body.
The human body is made up of 70% water, which is composed of hydrogen and oxygen atoms. The MRI uses the magnetic properties of the hydrogen atoms to produce images. The MRI machine has a primary magnet that is used to create the primary magnetic field, which we know as B. This magnetic field is 3 Tesla, which is about 50,000 times stronger than the Earth's magnetic field. The machine's magnetic field forces the spin of the hydrogen atoms in the body to align with the primary magnetic field. The way this works is that we start off with hydrogen atoms in our body having random spins. Once the primary magnetic field is turned on, all the spins of the hydrogen atoms turn to face the same way. A gradient magnet is used to create a weaker pulsing magnetic field, which is used to disrupt the primary magnetic field. This pulsing field causes the spin of the atoms to turn 180 degrees. At the end of each pulse, the atoms realign with the direction of the magnetic field. So, the atoms go from being in the direction of the magnetic field to turning 180 degrees and then back to being in the direction of the magnetic field. This realignment of the spins emits low-energy radio frequency photons, which are received by radio frequency coils. These frequencies are sent to a computer system which produces an image. The energy of each photon depends on the time and amount of realignment of the atom. The faster the energy is released, the brighter the tissue will be on the grayscale. This is based on the thickness and hardness of the tissue where the water molecules are located. For example, hydrogen atoms release energy faster in fat than in water, which is why fat tissue appears so much brighter in the image. MRI images allow doctors to differentiate between different body tissues by providing information about tissue density and shape.
Today, there are many different types of MRI scanners available to patients. Some of these include closed MRIs, open MRIs, upright MRIs, and conventional MRIs, which were described earlier. MRIs are very important instruments in the field of medicine because they allow doctors to examine internal body structures and diagnose a variety of disorders.